We'll move to our next speaker right away, but I just wanted to point out to all of you that a poll question was launched, so we would love for you to take a moment and respond to that in the next little bit. Okay, now you are in for a real treat with our next presenter. He has not only built an incredibly regenerative organic system, but he also exemplifies the curiosity, innovation, and mentality necessary to take on systems change. Rick Clark is a fifth-generation farmer from Williamsport, Indiana. The main goal on the farm is to build soil health and achieve balance with Mother Nature. Rick has developed and is constantly improving a systematic approach to regenerative farming. He is most proud of incorporating regenerative farming practices with all the acres being certified organic. He calls it regenerative organic stewardship with no tillage. He will suppress weeds and build soil health with cover crops and no tillage, things that he will probably tell you a little bit more about today. And he also cares deeply about human health, very much in line with what we just heard from, as it is another important driver behind the organic no-till style of farming. So please welcome Rick Clark.
Thank you. This is awesome. Thanks for having me here today. I appreciate it. John, that was a great introduction into Regen Rev. Thank you so much. You have so many insightful thought process. We greatly appreciate that, John. Thank you. Folks, this right here is where I like to start. This is my immediate family. You need everyone on board to be behind you with what you're doing, because what we're doing is so radically different from mainstream, and it takes everyone, and these folks all have my back, and that's so important because we are doing so many different things, and I need everyone on board supporting what we're trying to do. At home, and home, by the way, is West Central Indiana. We are right on the Indiana-Illinois line. And most people know where Champaign, Illinois is. If you just bring Champaign straight east into Indiana, you will run into our farm. And most folks here plant two crops, corn and soybeans. We are trying to get as many crops as we can. We're up to 9 right now. No particular order. It's corn, soybeans, wheat, alfalfa, peas, milo, cover crops, sheep, cattle, and a +1. The +1 is a regen year. When you get a field out of step, you sometimes need to get back, and that's what we call regen, and that's where we focus on massive cool season cocktails followed by warm season cocktails, and then we can try to get this field back into the timing that we need it to be in, to be within the rotations that are so necessarily needed. Now, I've been thinking a lot about this 9-crop system. And the more I hear John talk, and the more I hear other folks that are in this space talk, you tend to think, and you should think, and you don't want to become stagnant. You need to always be changing. And I'm just wondering if sometimes we're not growing the right crops. So when I look at corn and I look at soybeans in particular, those two, I can't imagine could be much more harmful to a human than those two crops. So I've got to be thinking about maybe camelina, maybe kernza, maybe ancient grains. I think I need to open up even more and start looking at 10, 11, 12 different crops to start raising. But anyway, that's just kind of where my brain is. 5,600 acres certified. Remainder of the farm is in transition. We've now used no starter fertilizer, no fungicides, no seed treatments, no insecticides for 9 years. We've not added any P or K in 9 years. And folks, I have to stress here, you just don't get done listening to all these great speakers on Regen Rev and decide that this spring you're going to just change your whole system and start taking fertilizer away, taking all these inputs away. It does not work like this. It is a systematic approach. It's time. It is a building process. It's a journey. You have to build into this, okay? no ag lime in 9 years, and no nitrogen applied in 4 years. We're trying to do everything with either cover crop rotations, cover crop diversity, or legume packages. And we're trying to do this with no tillage. Now, I do want to also state here, I have been pounding on no tillage for a long time, and I'm not saying that that's not the correct thing, but I am saying this. Sometimes we need to look at a situation, and I'm just talking about a field, not your whole farm, but just maybe a field. Sometimes we may need to do the reset. A reset may require some light tillage. Maybe the field has gotten rutted up with some harvest, or maybe we had some pattern tile put in place. That was a field that we had 2 years ago. We pattern tiled. We never worked it. The spring of 22, that we worked that field for other reasons than that. But that was what I looked at as a reset. I think we're okay. I'm not saying, though, that we're going to get into a tillage mindset here. We're not. I'm just saying that we need to add flexibility here sometimes and become a little less rigid than I've been in the past. All right, John mentioned this earlier in his presentation, but folks, if you don't know what these are, this is where it all starts and stops, right here. If you are going to be regenerative, you have to minimize soil disturbance. That is minimizing tillage and minimizing chemical disturbance. That's what they mean by this. Maximize diversity. We have to maximize diversity. There's so many ways to look at this. Maximizing diversity within cover crop species. If you're new to this game, you're going to only want to start with 1 or 2 species. And then as you become comfortable and more in tune with what's happening with this totally different way to farm, you then start adding diversity by adding more numbers of species to the mix. Also, diversity I look at is annuals to perennials. If you think about most of the cocktails that are made, they're almost all annuals. So we need to think about how can we add a perennial in to get diversity within that cover crop cocktail. But we also have to remember, what is the end game for termination? How are you terminating these cover crop packages so that you can then raise your cash crop? Let's assume that you're still using some chemistry. Then throw everything you can at it, because the chemistry, as I know, will still take care of annual ryegrass, Italian ryegrass, all of these things that are perennials, so to speak. But if you are a mechanical termination, then you need to be aware of what you're adding to these packages, and you have to look at diversity in other ways. So, for example, what we're doing now, and I'm going to talk about this a little bit later, and I'm going to these are referred to as Maslins. When you take like a barley, a rye, and a wheat, and you mix them together, and that's what you're going to plant in the fall, because you've reached a point in the growing season where cold weather is upon us, and it would be a waste of time and money to add any warm season species that are going to winter kill. So what we're trying to do then is diversify through that grass, diversify wheat, barley, rye, and I'll talk about that in a little bit. Living roots. Dr. Chris Nichols talks about living roots. You need at least 280 acres a day of living roots. I would like to challenge that and go even more. Obviously, this is all about where you live, what is your context, but we need to have living roots as much as possible, because these microbes like to eat every single day, just like we do. So when you go on a 40 or a 75 or 80-day hiatus, that's not good for their health. They may not survive. Armor the soil. It's all about protecting everything you're trying to do. We're trying to increase aggregate stability. We're trying to increase water holding capacity. We're trying to increase water infiltration rates. I mean, right now on our farm, we have water infiltration rates of 20 inches an hour. We have earthworm counts of 1.5 to 2 million earthworms per acre. when you spend most of your farming career building this system and getting to this point, you don't want to lose it all by not having the soil armored and having the sun beat down on it and absolutely crushing all the microbes, if not killing them. And the armor is protecting the soil and minimizing evaporation. I want that water in the profile. I don't want it running off in the ditch. I want it in the profile. And then when it's in the profile, we want to put like a lid on it and keep it in there and make it useful to the plant, not sending moisture into the atmosphere that is affecting climate change. Context, where are you in the world? I'm telling you that principle 1, 2, 3, and 4 work anywhere in the world. But how are we going to deal with these species? What species are we going to plant? When are we going to plant them? How are we going to terminate them? It's all about context. Livestock. If you want to build soil health, the quickest way and the most efficient way, it's with the incorporation of livestock. Now, this is not for everybody, but sometimes you have to think about what's in your area. Do you have dairies in your area? Do you have feedlots in your area? Maybe the best cattle to have are not your cattle at all, but somebody else's. You build the fence, you dig a well and get a water supply. You have the cattle come in for 3 months. The owner of the cattle is going to pay you a rate of gain, some negotiated rate of gain. You're going to build soil health. You're going to get paid to have those animals on your acre. And it's a win-win for everybody. And now you're setting up a huge success for the next cash crop. And if I could be allowed to add one more, I'd like to add 7, and it's commitment. You have to be committed to doing this. I mean, John laid this out so well in his 20-minute talk before this presentation. There are so many more people that have to be committed here than just the farmer. We cannot always put the burden on the back of the farmer. Thank you, John. You are so correct. Everything that we're trying to head toward is balance. We need balance between predator and prey. We need balance between bacterial and fungal. When we started down this journey of pulling out of high tillage environment, high fertility environment, and a high chemical environment, we were pretty much 98% bacterial. That's not where you want to be. As you move through time, you shift from a bacterial dominated system to a more imbalanced system between bacterial and fungal. And this is what you want. I actually want to be a little bit to the heavy side of fungal, maybe a 55-45 or a 60-40 type, but I don't want to go any more than that because being all fungal is not good either. It's all about balance. And when you get to balance, you then can start taking away the N or the P and the K. You can start taking away the seed treatments. For example, when you start taking away the seed treatments and you no longer plant GMO seeds, you now are trying to get balance in your soil profile so that whatever the species is that preys on the roots of the corn or that preys on the corn rootworm, you need that species in balance to keep that rootworm at bay. That's what I'm talking about, balance. Take advantage of the free stuff. This is the formula for photosynthesis. Now, folks, I'm not a biologist. I wish I was. I don't know exactly how all this works, but here's what I do know. We need to maximize the amount of oxygen and the amount of sugar that we are pumping into the ground. That is done through this right here. And to maximize this, we need a living, growing plant as many days as possible to take advantage of the full benefits of photosynthesis. The energy, it's free, and it's the most powerful source known to us. Let's take advantage of it. Here's what I'm talking about. I love this chart. This chart was built 5 or 6 years ago. We decided that I wanted to know what is out there growing in our fields. What is in the above ground material that's growing? So here's what you do. You measure out a 2 foot by 2 foot square. Okay, let me back up. I get a little ahead of myself. This was a cornfield in the fall. The corn was harvested. We come in with our no-till air seeder, and we seeded 100 pounds of Elbon cereal rye on 7.5-inch row spacing. Okay, that rye grew and it went into dormancy in the winter, came out of dormancy, started to grow, and then we took our first sample at 12-inch rye. Now this field is going to be a field of soybeans in the spring. Okay, we're going to plant beans into this. Now I wanted to know what is out there in the above ground material. So this is way back in the beginning of when we thought we could start pulling nutrients away. So actually I said 5 years. This is more like 10 or 11 years ago. Okay, at 12-inch rye, 82 pounds of nitrogen and 133 pounds of 0060. This is what was in the sample. So here, since we do this a lot, we go to the hardware store, we buy PVC, like 1-inch PVC pipe, and make a 2 foot by 2 foot square out of PVC pipe. You walk out in the field and you set that square down and you clip everything off inside of that square, and you put it in an overnight bag, you ship it to your lab, and you ask them for a feed analysis, and these are the things you get back. This is just some of it. There's many, many things that come back on this report. Okay, in 4 days, the rye grew 6 inches in 4 days. We now have 120 pounds of N in this above ground material, and we're up to 213 pounds of 0060, and we're at 4,000 pounds of biomass. Now, once you collect data and you start to look at the data and you start to understand the power that data gives you, you start to understand why it's difficult to plant corn into cereal rye. It's not impossible. You just have to understand what's happening. And as you start to look at this chart, you'll see that cereal rye sequesters the nutrients that young corn plant needs. So if you follow me here on this same line of thinking, this also works with weeds. When you come to our farm in the spring, you will not see hardly any broadleaf weeds. And this is why I think so. The rye is sequestering not only the nutrients that the corn plant needs, it's sequestering the nutrients that the weeds need. So now we've got the weeds buckled at their knees. The cereal rye is in rapid growth, so it is now canopying out and starving that weed from sunlight. That weed germinates, grows up, and dies. That broadleaf weed is no longer a problem for us. This is why I think we have to understand what's happening. So if you want to raise corn into cereal rye, then you have to bring nitrogen forward in the system. We no longer apply nitrogen, so I can no longer plant corn into this kind of a program. But if you are chemically terminating, or even if you're roller crimping, but still using some synthetic fertilizers, just remember to bring nitrogen forward, because you see why. Look at 28-inch rye. We're up to 134 pounds of N and 281 pounds of potash. This is why we no longer add P or K. Again, it's about context. I'm in the Midwest. We have good inherent soils. I cannot guarantee that you can totally remove all inputs no matter where you live in the world. I cannot guarantee that. but I know we can greatly reduce these inputs, 50, 60%, maybe even 70%. So again, I'm not the biologist here. I just know what's working on our farm. So please do testing on your farm. I came back 2 months later and took another sample. Thank goodness I did. And look at the amount of that's been exhausted here in just 2 months. So we have to understand that even though the rye has sequestered a bunch of nutrients, they're not all available immediately to the cash crop at hand. They need to be consumed by the microbes, digested, exhausted, and then they become a very stable state, like that nitrogen. When that nitrogen is converted by those microbes, it's now organic nitrogen, and it is very stable in the system. So if your cash crop does not utilize that nitrogen at that point, your next crop you're going to plant will, and that next crop you're going to plant should be a cover crop. So that cover crop is going to start soaking up those nutrients again. And this is what I call regeneration. We're bringing these nutrients from deep within the profile back to the surface, consumed by the microbes, put down through the profile, pulls through the profile again, and now is made readily available for your cash crop. That is regeneration. All right, now I took the same slide here and I just used the N, the P, and the K, and I want to put a value on this in today's terms. The 12-inch rye had 82 pounds of N, 32 pounds of 1846O, and 133 pounds of 0060. Those three added together are almost $230 worth of inputs. The 18-inch rye, $345 of inputs. The 28-inch rye, $435 of inputs. This is crazy how much money is out there if we just go down, unlock it, and regenerate it. And these are the numbers that I used on August the 1st of 2022. Now, they may have changed some. I don't know, because I honestly don't know, and I don't care because I don't buy any of this stuff anymore. But these are the values I use to make these calculations. That, to me, is powerful. Now, let's talk about nitrogen for a minute. 78% of the air that we're breathing right now is nitrogen. That's unreal. We have to start taking advantage of it. If you walk out the door and on any given acre, there is somewhere between 20,000 tons and 30,000 tons of free nitrogen that is sitting above every acre of ground. 20,000 tons. And how much do we need to raise a corn crop? 100? 120? Let's start putting the plants to work for us. Let's start reducing the synthetic loads. Let's start being regenerative. The power of Balanza clover, same thing. 2 foot by 2 foot square. You go out and you measure you collect what's in that square. You put it in a bag and overnight it to your lab, and they'll send you this back. This was on May the 20th. Now, now, folks, you have to remember, we are heading into 9 years now of a combination of no-till. Of course, we've been no-tilling on the farm now for about 17 years, but I'm talking about the combination of no-till and no chemistry for 9 years now on some of these fields. We are starting to get volunteer everything. We've got volunteer rye, we've got volunteer vetch growing, we've got volunteer clover growing. So this was a cocktail that was planted in the late summer, because when you plant a legume package and you live in an environment that gets cold enough to freeze, you need to plant these legumes no less than 45 days before that freeze event, because you need them to be able to survive the winter. So this was a predominantly based fixation clover cocktail, but it had many species that winter killed in it, like oats, sorghum Sudan, radish. These all terminated in the winter come out in the spring, we've got basically clover growing, but we've got some volunteer vetch and a little bit of volunteer rye growing. I just want to make that clear here. On June the 4th, 114 pounds of N, 213 pounds of K2O, and 61 pounds of calcium, and we're up to 6,800 pounds of biomass. Now, folks, 4 days, again, 4 days. Look what happens. This is geometric. Now, do we need to apply any more synthetic fertilizers when you see stuff like this? Now, let's be realistic here. We are organic, we're no-till, and we're all cover crop. And it's a young system. We are trying to make it better all the time. I am striving to get to 200 bushel corn on a consistent base. That's my goal here. But today, what is realistic? It's 5 years old. It's young. I hope to get 120 to 140 bushels of corn. If you do a factor of, say, 0.8, you don't need much more than 100 pounds of N. Right here on June the 8th, those plants have fixed over 260 pounds of N. Now, is all of this N available today? No, it's not. But I've been doing this a long time. Half of this is available. So take half of your 260, you're left with 130 pounds, and the remainder, the other half, is going to release as the growing season goes on. And look at our biomass. We are now up to a level that will suppress weeds. But look what happens here in 6 weeks. It's almost all exhausted. So now that biomass that we laid down is being eaten up from the bottom up. It now has holes in it. Sunlight's coming in. And guess what's happening now? Weeds are going to want to start to germinate, because not only do we have the fuel for the corn, we now have the fuel for the weeds. We have just given a huge flush of nitrogen. Okay? I have a 70-30 rule. 70% of the weed suppression is happening with the cover crop, and the other 30% is happening with the cash crop canopy. We have to get this corn to canopy in a hurry. We plant corn on 20-inch row spacing. I think one day, if we were to update equipment, we might go to 15-inch corn, because I believe this is going to give us even quicker canopy and better weed suppression. All right, that sample was taken on June the 8th. Carbon to nitrogen ratio was 20-1, which that's a little high for a legume package, but like I said, we had some volunteer rye in there and some other things, and it raised that carbon to nitrogen ratio. Okay, same thing, NP and K. I got to keep moving here. NP and K, May 20th, $291 of value. June 4th, $470 worth of value. Hang on to your hats. Look at this one. Almost $1,000 worth of value of just NP and K. I don't have any other nutrients or anything in there. Nothing. Just the N, the P, and the K, and that is where we are. And then on the 6 weeks later, there's still $120 worth of value. Now, what I need to do on some of these tests, like this rye test, we're changing the rye test. We are pulling a sample every Monday, and we start on the first day when we think the rye has come out of dormancy, and then we're going to run all the way through until I think the ground freezes, because I want to see where are we peaking and where are we totally exhausting, if we're even totally exhausting. This is where, and I'm going to talk about it in just a little bit, but we need a biological package running with us here. And I've been too stubborn to do this, but I am now telling you to do this now. AEA has tremendous products. Get joined up with one of their team members and figure out a systematic biological program to run side by side with your systematic regenerative approach. And then we can get to these levels even quicker, and we can start reducing the dependency on the synthetic inputs. Again, this is the dollars I use to make these calculations. All right, let's move on. Systematic approach to regenerative farming. These are my ideas. It's kind of a play on the 6 principles, but it's also adding other things. No-till, minimum till, cover crop species diversification. We have to have cash crop rotations. I've already told you we're up to 9 now. I think we need to probably get to 12 or 13. We have to greatly reduce chemicals, if not eliminate them. We have to do the same with synthetic fertilizers. Water infiltration. Folks, we don't have a flood problem in the world. We have a water infiltration problem. Most tilled soils have and I don't even know, you can't even say that this is a conundrum. They have no infiltration, but their infiltration rates are a 1/2 inch an hour. That's basically zero. When you get to where we are, we have aggregate stability now that's 8 inches deep. So just envision a glass jar full of marbles and look at all of the airspace that's in there. Remember earlier I said I'm not a biologist. I just know that we have to maximize the amount of sugar and the amount of oxygen that we pump into the ground. That is why we have 8 inches of aggregate stability that is a living, breathing organism that is taking in oxygen and exhaling carbon dioxide. Guess where the stomata is on a corn plant? It's on the bottom side of the leaf, and that's where the CO2 is coming from to get to the stomata. Imagine that. The system's already in place. We just need to maximize it. Systematic biology program. I just talked about it. I have been extremely stubborn up to this point. I was arrogant enough to think that we were going to grow our own biology, and we are. But we have to remember this biology has been asleep for hundreds of years because it has no job. All the tillage takes their houses away. They can't live anymore. All the fertility takes all their jobs away. So there's nothing for them to do. So we need to have these biology programs running side by side. Livestock grazing, already talked about this. It's very important if you want to build the quickest and the most efficient way. But folks, don't get hung up on this. If you are allergic to cattle, then by all means don't have cattle. This is not a game stopper. If you don't have livestock, don't think this isn't going to happen. It will happen. It's going to happen quicker and more efficiently with the presence of those hooves, the saliva, the urine, the dung, all of these things. Co-mingling cash crops. This is where I think the future is. I think when we've been doing this for 2 years now, we plant peas and wheat together, and then we separate them. We plant soybeans and wheat together. We either separate them or they may get fed. They may get taken off as a haylage. All of these things give a different diet to the dairy animals. Believe me, they want diversity too. So we need to think about, if you have a dairy around, talk to them, talk to their nutritionist, figure out plans to build forage packages that benefit you and them together. And co-mingling of the cash crops is where it's all going to be. And I'm going to do, the next one we're going to do this year is we're going to plant milo and soybeans together. We're going to harvest them together and we're going to separate them. I think that'll be a great combination. Stability. This is probably the most powerful slide I've ever built. And standard deviation here is yield. So when you look at time on the bottom and yield on the vertical, this is what's happening here. Okay, the first timeline is 2010. We started our journey to the left of this. All right. But as we got into the journey, the system took time to make the adjustment. It took time to build aggregate stability. When we started, we had none. We quickly got an inch, but then we stayed at an inch for 4 or 5 years. Then we went to 2 inches. Then it really started to take off. If you can totally eliminate tillage, it is absolutely unbelievable what happens to your soil tilth and your aggregate stability. It's unbelievable. Okay, so as time marches on, the system is becoming more stable. So in other words, when we pulled into a field of corn to harvest corn and took off with the combine, we would have 30 bushels of yield variance through the field. Now that the cover crop program, the no-till, the microbes, all of this is working in a systematic, synergistic system, we now are less than 5 bushel. This is when we were at the height of our days of being regenerative before we went organic, okay? This right here is 100% no-till, 100% cover crop, and 70% reduction of inputs. That's what this chart right here is telling you. You can only build charts like this when you collect data, and that's what we do. Epigenetics. Heritable phenotype changes that do not involve alterations in the DNA sequence. These phenotypic trait changes may result from external or environmental factors or be part of normal development. This is where I am going to spend most of my time. I'm going to spend it on epigenetics, and I'm going to spend it on learning more about biology, about stimulants, about hormones. How do we turn on certain groups of microbes? How do we turn off others? We have to create environments that weed species do not want to germinate in, and we can do that with biology and soil health. Let's stay right here though. Epigenetics. This is what I'm talking about now. Keeping seed and not introducing any more seed ever into the system. Now, we have to lay the rules out. You cannot bin run soybeans unless they're off patent. Okay, this is very important. So what we did was we went back 30 years. The USDA has a building in Colorado. You Google it. That'll give you a book. It'll tell you what they have in inventory. Every known seed to man and woman is in that building. So we went through the soybean library, and I'm just going to tell you where I went. I went to Asgrow, and we purchased 10 genetic varieties that were off patent. So it's legal to reproduce them, and it's legal to plant them again year after year after year. So we have now just finished year 4, and we harvested 40 acres of genetic beans that are 30 years old. They're ours. Okay. Now, here's what I did. Right, wrong, or indifferent. Okay. I created a land race here. We took the 10 down to 5 after year 1 because I didn't like the way 5 of them were working in our system. We then took that 5 to the next 3 years, and this year completed year 4. We harvested 40 acres of these, and I commingled them all together. Because how do I know which one is going to work best in the system over time? So I'm going to let the system decide which soybean variety is going to be prevalent and succeed here. This is all about epigenetics. We're going to do the same thing with corn. We've done it with open pollinator. And again, folks, I cannot stress enough, you cannot bin run anything here unless it's off patent. I hope everyone understands that even a non-GMO soybean cannot be bin run. I hope we understand that. Yes, there are no traits on it, but the genetics are patented. So we cannot do this until we do genetics that are off patent. We do the same thing with livestock. We've been doing it for 2 years now with the cattle and 2 years with the sheep herd. We find our breeding stock from within the herd. We are trying not to introduce any other genetics in the herd. Same thing with biology. We're trying to do the same thing with the biology. Try to epigenetic the biology you have. Help the biology you have. All right, epigenetics. Maslin, this is what I talked about earlier. This is a 3,000-year-old tradition where you grow a wheat, a barley, and a rye together, and you harvest them together, and then you make a bread out of those 3 species. That's a Maslin. That's what we're doing to get diversity here. Remember, I told you you've got to diversify any way you can. When we get to a certain point in the fall, we have ran out of time to what we can plant. We're basically down to cereal grains. That's it. So we were always just planting cereal rye. I think we have overused cereal rye. So we have to think about how do we get diversity. So I got to thinking, I thought of this 2 years ago. I said, why don't we just add rye, barley, and wheat together, and maybe triticale if you got enough time left in the season, and let's create this commingling, and that's going to be our late season go-to cocktail. And then wouldn't you know it, about 6 weeks ago, I'm reading an article about Maslins. I'm like, what's a Maslin? So I Google it, and that's when you add these species together, and I did it 3,000 years ago. I'm like, wow, I've been doing this for a couple of years, had no idea. So there are forces at hand here, folks, that are pushing us to where we need to go. All right, this is how we plant beans. I'm probably running up on time here. I've got maybe 10 minutes left. This is beans at boot stage. We're pulling in with our planter. We're no-tilling. There is no coulter on here. There's not a no-till coulter. There are not any row cleaners. It's a double disc opener and a closing system. We're trying to do this at boot stage. Then we come back and we roll when the rye is in anthesis. Okay, this is our termination plan, and this is our weed suppression plan. Now the camera's going to pan to the right here in just a moment, and when you see this dust, that's not dust from the field. That is the dust from the pollen of the cereal rye. Look at that. That's when you know you're out there at the right time. Now, when I set up a slide presentation like this, that first slide you just saw of the corn planter, and now this slide, it's the same field. This is the same field on July 19th. Now, this is going to be pretty good. But as you can see, these are 20-inch row beans. And if you look down the middle of that slide, you can still maybe see the dead rye down there, the brown stems that are on the ground. They are starting to get holes eaten in. The sunlight's gotten in because we haven't got the canopy yet. There will be some escaped weeds here, and foxtail is going to be one of them. Okay? This particular field, though, nope, I didn't have the harvest slide. I'm sorry about that. I didn't have the harvest slide. Maybe I have it on this one here. Now, this is another way to think about this. Again, you've got to always be ready to change your plans, okay? We were going to come in here and we were going to do all of our bean fields like the slides you just saw. We were going to plant at boot stage and roll on June the 7th, and it was all going to be good. Well, in this particular year, Mother Nature decided to rain, and you weren't going to plant until June the 2nd. So the rye was at anthesis, ready to terminate. So I decided to roll the rye first. Now, folks, that rye is dead. That rye's dead. Okay, here comes the planter right behind it. Now, there are row cleaners on this planter, which they aren't anymore. They've been taken off, but they are up. They're not doing anything. And if you look, you can hardly tell that the planter even planted through that. It's hard to tell that the planter was even in that field. That's what the beans look like on July 16th. This can be done. We can do this. We need biomass. And the best way that I know of to get biomass is to plant diversity and plant early in the fall. You have to give yourself plenty of time to get to this point. Here's the combine slide. I'm sorry. This is now combining that same field. I'd say that's pretty clean. Now, not every field is like this. We are struggling with grass right now, but we're working through this. We've got John's helping me. We've got ideas on the table. We're going to work through this foxtail issue. Okay? That is going to be our last stumbling block. Here's how we plant corn. We no-till corn into standing alfalfa. And again, folks, I cannot stress how dangerous this is. We're planting a warm season grass, corn, into an established perennial of alfalfa. But these two work well together. Believe it or not, the alfalfa will actually bring moisture to the corn plant through evaporation. So this will work. We need some help from Mother Nature. So you go in, you plant your corn. The alfalfa is at about 50% bloom. The reason why I'm doing it this late, and that's not that late, it'd be right around Memorial Day, maybe June the 1st, because I want the alfalfa to stop doing anything. And when alfalfa makes its seed, it will stop unless you cut it off. And then when you cut it, it wants to regrow. Well, when it regrows, it's now competing for moisture for the corn, and it's taking nutrients that the corn needs. So we want to do this at 50 or 60% bloom. Then we come back and we roll this down. Now, corn's at V2. It's about this tall. Now, we know this isn't going to terminate the alfalfa. We know that. But what we're trying to do is give the corn a head start to get, look at that picture. Isn't that beautiful? That alfalfa is laid flat. Now, we need the corn to get up and go. We need a rain event to get it going, and you get to this. Now, on August the 2nd, this is what we've had. So, folks, this is zero tillage. This is zero inputs. This is no-till corn into alfalfa, and we grow. Remember I told you my 70-30 rule? 70% of weed suppression is with the cover crop / alfalfa. There were no weeds in those alfalfa fields, none. So the weeds are taken care of. Then this 30% is now the cash crop canopy. And when you get your 20-inch corn row spacing to canopy, and it smothers that alfalfa, it terminates it. We have done this for 4 years. Now, I have to be totally transparent with everything we're doing. In 2022, it did not work. The corn died. We hit 7 weeks of no rain and 92 degrees. The corn died. That's okay. We have outs. We took the field back to alfalfa, got 3 good cuttings to the dairy, and still got income off of that field. We will now do that again in 23, do the same thing, do it again. But when the corn gets to canopy, it will suffocate and smother and terminate the alfalfa. It's done it for us 3 out of 4 years. I can go back to the first fields that we had this done in, and the alfalfa's gone. Okay? Input reductions. From 11 to 22, we have reduced diesel fuel by 50%, horsepower by 64%. We now no longer use any synthetic any MAP, potash, lime, or chemistry. Okay, now what does this savings mean? On diesel fuel, $62,000. On synthetic N, $605,000. MAP, $334,000. Potash, $347,000. Lime, $126,000. Chemistry, $483,000. And I've added one more seed because we're starting to keep our own seed now, and we're keeping cover crop seed. We're doing everything with epigenetics now. Livestock, cash crop seed, cover crop seed. But again, it has to be off patent. We are saving $2 million a year on a farm our size. So if everyone thinks that I'm wacky crazy about everything I'm doing and I'm wrong by half, we're still saving $1 million a year. That is real money. If you are not uncomfortable with what you are doing, then you are not trying hard. Read that again. If you are not uncomfortable with what you are doing, then you are not trying hard enough to change. I challenge everyone here today to get a little uncomfortable. I think you'll like how it feels. I am proud to be a farmer, but I am way more proud of the way I farm. Regenerative, organic stewardship with no tillage. Thank you. Thank you so much for your time. And thank you for allowing me to present on this platform. It's been an honor. Thank you.
Great. Awesome information as always, Rick. Thank you. We do have some time for some questions. We have a ton of questions, so we'll see how many we get to, but let's hop right in.
Okay.
Maybe that's why they call this hop in. Okay, so first question. When commingling cash crops, how do you determine which combine settings to use?
When commingling the cash crops, we had to do this through trial and error. And actually, the very first time we did this was an accident. I wanted to plant beans into wheat and do what the people out west call relay cropping, but not have the relay cropping is 2 rows of rye and then 2 skips and then rye and then skips. Then you come back in the spring and you put the beans in those skips. I didn't want to do that. So we drilled the wheat with a 7.5-inch drill in the fall, came in the spring and drilled beans into that wheat and let them grow together. The plan was to harvest the wheat over the top of the beans when the wheat was mature, but the beans outgrew the wheat, so we couldn't harvest the wheat. So then I said, okay, fine, let's just let it go, and we're going to harvest the two together. Couldn't believe what we had at the end. Now, will this wheat be a food grade wheat? Probably not, because it's been mature since July and it's being harvested in October. So then that's when you talk to the dairy, or what we're doing now is we have a cleaning system. We are cleaning and separating out, and that's the basis of our cover crop now for that next year. So to answer the question, it was trial and error, but soybeans will work with any of the cereals. Peas would work with any of the cereals. I think fava beans and corn would work together. I think milo and soybeans would work together. And I think a short statured corn and soybeans would work together. So try on your own farm and see what happens.
Right. Great. Okay. Some technical questions. What type of crimper are you using?
It is an I&J roller crimper. That's in Pennsylvania. And I forget their webpage. It's not I&J Manufacturing because somebody else had that, but it's capital I ampersand capital J roller crimper, and that's out of Pennsylvania, and it's 60 feet.
Nice. Thank you. Okay. I want to switch to biology a little bit here. Do you think you'll start using biology on your seed, in your soil, or both?
Yes. I think what we're going to do, and again, I need the guidance of professionals, and I cannot stress enough of how important it is that you source people that know what they're talking about. AEA knows what they're talking about, okay? I'm not trying to just give them the plug, and I don't get paid for this, but I just try to tell people what I think is valuable information. They are a valuable source. Okay. We are going to figure out a program that will put biology on the seed, biology in the furrow, and biology foliar feed. And I want to go one step further. And when harvest is over and your cash crop is growing for next year, I want to start foliar feeding that cover crop to get ready to go into dormancy. Now, I've got one more thought process I want to get at here on biology. Again, I'm new to this and I love to test. So what we're going to do is we're going to go out and we're going to pre-plant biology. Here's what I mean by this. We're going to go out, I hope, 3 to 4 weeks before we want to plant our cash crop, and we're going to in-furrow biology. And I want the biology to be out there early and start working toward building and energizing everything so that when the cash crop gets there, that now has a seed treatment on it, and we're going to furrow feed it there again. But think about the environment that seed has now been dropped into, everything is energized. And my hope is to get the cash crop out of the ground 2 to 3 days sooner than normal. And now we're off to the races up and off to the races down with the roots going down.
Nice. So this is a follow-up question. You kind of answered in that question, but just want to keep on the biological theme here. When do you think biological applications will be easiest and or give the best return? Sounds like you're trying a lot of different things.
Yeah. And again, it's all about what equipment do you have? I've always said, don't go out and buy any new equipment. Try to use the equipment you currently have, see if this is going to work for you, and then go buy something that you may not have. So for example, and again, I'm talking testing here, 1 or 2 or 3 acres. You don't need to go buy some $50,000 seed treat equipment. Mix it up in a 2.5 gallon sprayer, spray it onto your seed as it's going up into the seed tender. It'll give it time to dry. And then when you get to the field, then put it into your planter and plant. I mean, that may sound archaic, but it's a way to see if that type of biology is going to help you. But still, you need to figure out, you've extracted X amount of microbes out of your solution, or you've bought an AEA product and you want to make sure, okay, this many pounds is supposed to treat this many pounds of seed. So you still need to do the calculations correctly and get it applied on your seed that way. And then when you see that it's going to work, then you start to add on any equipment that you may not have.
Perfect. That's great. I know we had a few more questions here, but I'll keep us moving along here. I will ask actually one last question here. And this is a specific question, but my rye doesn't seem to break down. This is one of our audience members. My rye doesn't seem to break down. If my soil isn't active with microbes, will my nutrients be tied up longer? Is that what you think is happening?
Yes, it will. And again, John and his company have products to help that breakdown process. But yes, what's happening here is you don't have you probably don't have enough of the correct microbes that need to do the job to break that rye down. And we've also got to remember here too, that a rye environment at termination is probably 80 or 90 to 1 carbon to nitrogen ratio. So this really wreaks havoc on the system because there's so much carbon going down at the beginning here. So we need the biology there to bring this to a quicker degradation and get it into the microbes that can consume it quicker. So yes, I totally agree that the rye needs to break down as quick as we can get it to break down.
Great. Thank you so much, Rick. As always, we learned a ton. And I think hopefully we'll have you back here later today for the Q&A at the end of the program with all the speakers.
Yes, I plan on being here. Thank you.
So if you have more questions for Rick, please save them. He'll be back.